Hello and welcome to our lesson today. Today we are going to talk about factoring by grouping, and then we are going to move on to learning about factoring the sum and difference of two perfect cubes. Like I just said, the first type of factoring that we are going to talk about today is grouping. And when should you be doing grouping? Because usually when you are asked to factor, you will be just given an expression and you will be asked to factor. You will rarely be told like, hey, do this type of factoring or do that type of factoring. You'll have to ask it yourself and then determine what type of factoring you should be doing. That is exactly the first step, okay? So for grouping, you should be looking out for 4 terms. That's the key thing there. You can only perform grouping or you can only factor an expression by grouping if it is a polynomial that has 4 terms. Like the example in here has. I drew 4 boxes which resembles 4 terms, right? So once you figure out that, yes, I have 4 terms and yes, I should be doing grouping, then you should group the first 2 terms together into one group, and you should be grouping the second 2 terms into another group. So in total, there will be 2 groups, and those 2 groups will contain the 4 terms that you originally had in your expression. So that is, so that is noticeable in here. So look, you group the first 2 terms using parentheses and you made that a group. And then you group the second 2 terms using another parentheses and you made a second group. And there you go, your 4 terms have been grouped. And once you do grouping, or once you are just done grouping the terms, not done doing the entire grouping method, you are supposed to factor out the GCF. And you should be factoring out the GCF from each of the groups that you just formed, right? So if you take a look at the first group that you just formed, you should be figuring out the GCF of 3x squared plus 6x. The GCF of, let's break it down. So 3x squared, and then you have 6. So let's break it down. So the first thing that we should be doing for our GCF is figuring out the number, because I know that my GCF should have a number as both of the terms have at least a number, right? So my GCF, what is the GCF of 3 and 6? It's 3. And the GCF of x squared and x is just actually x. And how do I know that? Well, if you are working with variables and exponents, right? So then you should always pick the variable with the lowest exponent, which in this case is just x to the first power, right? Because 1 is like, literally lower or like less than 2. So then I should be picking the variable with the lowest exponent, which is just x to the first power. So I'm going to write that here, which is exactly what I have in there as my GCF. Once you figure out your GCF, you should be dividing each of the terms inside the parentheses using your GCF. So your first term that you have in there is 3x squared. And if you divide that by the GCF, well, if you have 3 at the top, 3 at the bottom, they cancel out because you literally have the same thing on the top and the bottom. And you have 2 x's at the top, 1 x at the bottom, so you can cancel one of the x's from the top. Well, one of the x's from the top and the x at the bottom, and you will just be left with x. Which, if I wanted to show you guys, goes like this. So you have 2 x's at the top, 1 x at the bottom. You cancel out these 2 x's because you have the same thing on the top and at the bottom, and then you will be just left with an x, which is what I wrote in here. When you do that, you are supposed to divide your second term using the GCF, and your second term is 6x, and your GCF is 3x. I know that 6 divided by 3 is 2, and you have x at the top, x at the bottom, they cancel out. And you will just have 2, right? And it's going to be positive 2 because you divided positive 6x by positive 3x. Once you do that, you are done with your first group. You factored out the GCF, and you are done with your first group. And you do the same thing to your second group. So the first thing that we did to the first group was nothing but factoring out the GCF. So let's factor out the GCF for the second group, okay? Well, the GCF should have at least a number, right? Because it's 4x and then 8. Well, both of the terms at least have a number. So what is the GCF of 4 and 8? Well, it's 4. And then the second term does not have a variable to it, so your GCF cannot have a variable with it, right? So the only time you can have something as your GCF is when you have all of your terms having that thing, okay? So in this case, 8 does not have an x, so my GCF cannot have an x. My GCF is just going to be 4. And once you figure that out, you divide each of the terms using your GCF. So 4x divided by 4 is just 4. It's just x. I'm sorry. 4 at the top, 4 at the bottom, they cancel out, and you're just left with x. Once you figure that out, you're supposed to divide your second term using your GCF. 8 divided by 4 is just 2. And both of them are positive, so I don't have to include any other signs other than a plus sign in there. Once you do that, you should be able to notice something. You should be able to notice that you have something special. What is that thing? Like a color coded in here, you have like terms. You have x plus 2 and another x plus 2, and they are not like terms. I apologize for that. They are common factors. So after you are done factoring out your GCF, you should be looking for common factors. If you have a common factor, you are on the right track. You are doing it right so far. If you do not have a common factor after you are done factoring out the GCF for the second group, please go back and check your problem. You probably did something wrong, because that's the rule of factoring. You will have to end up with a common factor. So once you have your common factor, what you do is that you factor out the common factor. And after factoring out the common factor, you will be left with this, x plus 2, right? And once you do that, then you should be combining the terms or the GCFs that you have outside the parentheses. This one right here and this one right here. And notice they are, you have to carry down the sign of the GCF. So this was positive 4. So positive 4 comes down as positive 4. Please do not change the sign of that one. And then if you combine them, you'll end up with 3x plus 4. And that is your factored form of this given expression. And you just factored that expression using grouping. Okay, this expression cannot be factored any further. So now that we are done talking about it, we will do a practice problem together, because math gets better with practicing. So I'm asked to factor, and I know that I should be doing factoring. I should be doing grouping because I just taught you guys about grouping. But even let's just not think about it for a moment and ask ourselves that, should we be doing factoring? Should we be doing grouping as our factoring method? Well, I take a look at this expression and I see 1, 2, 3, 4 terms, and bingo, if I have 4 terms, I'm supposed to do nothing but grouping as my factoring method. So let's do grouping. So the first step of grouping is to group. I'm going to group my first 2 terms using I'm going to group my first 2 terms as in my first group, and then I'm going to group the second 2 terms in my second group. So my first 2 terms goes in there, and that's my second 2 terms. Yeah, so that's my first group using the first 2 terms, and that's my second group using the second 2 terms. So once you're done doing that, you are supposed to factor out the GCF from each of the groupings that you have in there. First terms in our first group that we have in here is what? So I should be asking myself, what's the GCF of 6 and 9? Well, the GCF of 6 and 9 is 3. And the GCF of x and then x squared, like we just did before, is just x, because whenever you are dealing with variables and exponents, you should always be picking the variable with the least exponent or the lowest exponent. Well, in this case, we had x, And then we had x squared. Well, obviously x is the variable with the lowest exponent, hence it is part of the GCF. Once you figure out your GCF, you're supposed to divide each of the terms using your GCF. Well, then let's divide each of our terms using the GCF. 9x squared divided by 3x actually gives me what? 9 divided by 3 is just 3. And then x squared divided by x is just x, because you have two x's at the top, one x at the bottom. One of the x's from the top is going to cancel out with the x at the bottom, and you will just be left with x. Once you do that, divide the second term using the GCF. And 6 divided by 3 is what? 2, right? And then the x's cancel out, and then you are just left with 2. So I'm going to put this one and this one together. So the order in which we write it is that we write the GCF first outside the parentheses, and then we put the dividend of the first term as the first term, and then we put the second one as a second term in there, right? So once you do that, you are done with the first group. So now you are supposed to factor out the GCF for the second group. So for our second group, what is our GCF? Well, I see that we have 12x and 8. My GCF obviously is going to have a number. So what is the GCF of 12 and 8? The GCF of 12 and 8 is 4. And the GCF cannot have a variable because only 12 has a variable. 8 does not have a variable. And as long as 8 does not have a variable to it, your GCF cannot have a variable as part of it, okay? So it is just going to be 4. Once you do that, you are supposed to divide each of the terms using your GCF. 12x divided by 4. Well, 12 divided by 4 gives me 3. And just x divided by 1 is just x. So I'm just going to write this as my first term. And my second term is 8 divided by 4 is 2. So then I should be looking for something that is our biggest clue that I'm on the right track. What is that? That is our common factors. Right? We have the same I would say binomial twice, right? And those binomials are my factors. Remember, we factored out the GCF, and then we have a first factor, and then we factored our GCF for the second grouping when we had our second factor. And those two factors are the exact same factors, hence those are my common factors. And if we see that we have our common factors, that means we are on the right track. So then what is our next step? Well, my next step is to factor the common factor. And then, so I factor out the common factor. And then whatever I have outside the parentheses, which is also our GCF, I put them together. So 3x plus 4. This is your factored form of the expression given in here, done through grouping. So this expression cannot be factored any further, and that should be your answer, which is option A in here. Okay? All right, so this is actually the thing that I was talking to you guys about. So this is grouping. We are gonna still do grouping, but then the polynomial that we are going to work with is going to have a negative coefficient, right? So the only difference is this in this part here, right? In the problem that you just worked with, this problem had this positive sign in here, whereas this one, it has the negative sign in there. Right? So your third coefficient in the previous problem had a positive sign, and now the third coefficient has the sign of a negative, it has a negative sign, right? And why is that a problem? Well, you know that your third coefficient, or the third term rather, that is actually your first term for this group, right? Because you know that the first two terms, they form one group, which is your first group, And the second two terms, they form your second group. And then the third term, right, I just said, this is actually the first thing that comes here, and you see that you have a negative sign there, right? So that is the only difference in this one, right? Because we just worked with polynomials with positive coefficients, now with negative coefficients, but they work out exactly the same way when it comes to doing grouping, right? There might be an extra step or two, but that is not a lot of work. So then let's do it. So like we did for our previous problem, we are going to start off with grouping, right? Grouping. So we are going to group the terms. So let's group the first two terms as our first group, and let's group the second two terms as our second group. Okay? So notice that how I still kept the positive sign, but then I just made this one negative because I had to like bring down the sign, whatever it originally had, into my grouping. Okay? So once you do that, you have formed your two groups. Now you do the exact same thing like you did. You have to factor out the GCF from each of the groups. And what is the GCF of the first factor that you have, the first group that you have? Well, my first group is actually 3x squared minus 6x. So what should my GCF be? My GCF, I know, has to have a number because 3 and 6 are both numbers. And what is the GCF of 3 and 6? It is 3. And then I have x squared and x. I picked the variable with the lowest exponent, which is just x. What I have in here. And then once you figure out your GCF, you are supposed to divide each of the terms using your GCF. And when you do that, what happens? You're supposed to divide this term. You're supposed to divide this term. So if you divide the first term, which was 3x squared, by 3x, well, the 3's cancel out, and one of the x's from the top is going to cancel out. It's going to cancel out with the x at the bottom, and I'll be just left with x, which is what I have in here. And then negative 6x divided by the GCF, which is again 3x. Negative 6 divided by 3 is negative 2, and then the x's cancel out, right? So bingo, I'm done with the first group. I factored out the GCF. Now here's what is going to be a little different for the second group in comparison to whatever we have been doing, right? So what is actually going to be the difference? Well, the difference is going to be I will end up with a negative GCF because my leading coefficient is a negative number. So my GCF is going to be a negative number as my leading coefficient is a negative number. So the GCF of negative 4 and 8 is going to be negative 4. I mean, you can't just like kind of put the negative sign away and ask yourself, well, what is the GCF of 4 and 8? The GCF is 4. And then you can think of it as like, okay, so now I know that my leading coefficient is negative, so my GCF is going to be negative. So once you figure out your GCF to be negative 4, right, you are supposed to determine your factor as your next step. And how do you do that? You divide each of your terms using your GCF. Negative 4x divided by negative 4. So negative 4x divided by negative 4 is just x because you have negative 4 at the top, negative 4 at the bottom. And if you have the same thing in the top and at the bottom, they cancel out and you're just left with x. And 8 divided by negative 4 is negative 2 because a positive number divided by a negative number is actually negative, right? So that's going to be negative 2. Okay, so once you do that, you should be noticing that even after this whole thing that you just did with the negative, GCF, and then dividing a number with a negative number and all that fancy things, you are still working with common factor, right? So then now you know that even after doing all those messy works, you are still on the right track because you have common factors, right? And then you are supposed to simplify. And how do you simplify? Well, In the third step, I actually did something. So I wrote simplifying here, and the reason as to why I wrote that is because of this. There was a positive, and there was like I put the -4 in like a parenthesis. So now I worked my way through. So I distributed I multiplied the positive one outside of the parenthesis with the -4, and I got -4. You guys could have skipped this step and not do it, but then I just want to show you guys that that is how it got simplified. Once you do that, you are supposed to factor out the common factor, and then yeah, so you are supposed to factor out the common factor. So then that became 1, and then you are supposed to combine the GCFs. And notice how this GCF, the second one, right, in here, right, that was -4, so it's 3x minus 4. So here's the thing. So if you are working with, if you are doing grouping for a polynomial expression that has negative coefficients, you should have your second factor, right? So your second factor, right, that's gonna have a negative sign in it, right? So in this one, the first one is also negative because you have a negative coefficient in here. This polynomial expression, this actually had negative coefficients in multiple places. One in here and then one in here. So yeah. So the bottom line is that unlike the expressions with positive coefficients, if you're working with negative coefficients, you are going to have probably a variety of signs or like just negative signs like that. But it all boils down into you being able to figure out your GCF to be a negative, right? Okay, so in here, we actually have a practice problem with a negative coefficient. Or negative coefficients rather, because this one is negative as well. But then the only thing that is gonna change is this, that is gonna make a change is this one right there. I know that I'll have to do grouping because there are 4 terms in there. So let's group the first 2 terms into our first 2 groups and our second 2 terms into our second 2 groups. So my first 2 terms are 2x squared minus 3x. And then the second one is -4x plus 6. And I'm still gonna have the positive sign, okay? So once you do that, you know that you have to find the GCF of your first group. So what is your GCF number 1 or for the first group? Well, my GCF, I know that, well, here's the thing. I have been telling you guys that you can have something in your GCF as long as you have that as a common in between all of your terms, right? Well, so now if you look at 2 and 3, do they have any common factors other than 1? 2 and 3 do not have any common factors other than 1, so my GCF cannot have a number. It's gonna be only a variable. And how do I know that? Well, x squared and x, they have a common factor. And the common factor is x. Because I just told you guys that if you're trying to determine the GCF of 2 variables and you're working with exponents, you always pick the variable with the lowest exponent, which in this case was x to the first power. Once you figure out your GCF, you're supposed to divide each of the terms using the GCF. Well, 2 divided by 1 is 2, x squared divided by x is x. The second term is a negative number, so I'm going to divide the negative number by my positive GCF. And -3 divided by +1 is -3 because negative divided by positive is negative. And x on the top, x at the bottom, they cancel out and you're just left with 3. Once you do that, now I know that my GCF is going to be a negative. It's going to be negative because my leading coefficient is negative. And if I know that, I'm going to save myself some struggle by just putting a negative sign in there. Now I don't have to worry about the number being positive or negative. I just can ask myself, oh, what is the GCF of 4 and 6? Because I already put the negative sign in there. The GCF of 4 and 6 is 2, right? Because that's the greatest common factor. And then my GCF cannot have a variable to it because both of my terms, they don't have a variable in common. Only the first term has a variable. The second term does not have a variable. So my GCF is not going to have a variable. So once you do that, you are supposed to divide the first term, which was negative 4x, by your GCF, which was negative. And that turns out to be what? So your so if you're dividing a negative number by a negative number, it becomes positive. And 4 divided by 2 is 2. And the x divided by 1 is just x. So I'm going to write that. And then for the second one, it was positive 6 divided by negative 2. That should give you negative 3, because positive divided by negative, like we said in here, is negative. So negative 3. Right? So notice something. Even after that whole battlefield with having a negative GCF and then dealing with negative coefficients, we still accomplished our task. And how did we exactly do that? Well, we did that, and we know we did that because we have common factors. So we are on the right track so far. As our next step, you should be factoring out the common factors. And if you do that, you should have this, and then you combine the GCFs, x and negative 2. Please bring down the sign. And that's your factored form of this expression in here. And you did that using grouping. If this expression or this factored expression cannot be factored any further, this is the answer. So this is another practice problem that we have in here, and we are asked to factor. And like I told you guys, it does not tell me that what kind of factoring that I should be doing. It just tells me that I'm supposed to factor. Since I already told you guys that our today's lesson is going to be about grouping, and the other one that we did not learn about yet, you guys can probably guess that this is a grouping factoring problem. But yeah, if you didn't know about that, which is too obvious, you should still be asking yourself, do I have 4 terms? Check, you do. So you should be doing grouping. You were right. So what is the first step? I group. Then I factor out the GCF. What is the GCF of 5 and 10? So my GCF number 1 is 5, and my GCF is going to have a variable because I have x as a common factor between those two terms, right? So I'm obviously going to pick the variable with the lowest exponent, which was x. So 5x is my GCF. So once I figure that out, I'm supposed to divide each of the terms using my GCF. So let's divide, and notice how this problem is a positive coefficient. It's actually, we're dealing with a polynomial with positive coefficients. So now we're gonna do this. So 5 and 5, they cancel out, and x squared at the top, 1x at the bottom. You are just left with x. And then for the second part, you have 10 divided by 5 is 2, and then x is canceled out, so x plus 2. So then my GCF number 2 is going to be what? What is the GCF of 2 and 4? It's 2. And then that expression does not have a common factor of x, or that factor does not have a variable as a common factor, so my GCF is not going to have a variable. It's just going to be 2. And then I divide each of the terms. So 2x divided by 2, and 4 divided by 2. So 2x divided by 2 is just x. 4 divided by 2 is 2. And now you should be looking for that hint that should tell you if you are on the right track or not. And I think we are on the right track because we have the common factors. So after you have the common factors, you are supposed to factor them out, and then you combine the GCFs. That's your factored answer for this expression in here. Bingo! I actually wanted to talk to you guys about a technique, I would say. So I was gonna, okay, so we are gonna have a problem where I'm gonna show this technique again. So the technique is this. So we are gonna distill the grouping, right? And then we know that for our first group, the GCF was 5x. And we divided each of the terms using our GCF, and we got x plus 2. And now I'm gonna do something. I'm gonna reverse engineer my way back, right? So if I'm reverse engineering, I'm gonna work actually backwards by putting the common factor first. Because I know that in order for my grouping method to work, I should have a common factor. So then if you already put in a common factor, you ask yourself, what should the GCF be? Because usually you factor the GCF and then you have your common factor. But now you already have the common factor, and now you're trying to figure out the GCF, which is like working backwards. So how do you figure out the GCF? Well, you ask yourself, what should I times x by so that I will have x, right? So what should I times x by? Well, I think you should times it by 2 because x times 2 gives you 2x. So then 2 is probably your GCF. You can double check that by doing this. You just worked with x, so now let's work with 2. Does 2 times 2 give you 4? Yes, it does, right? So we checked for 2x, then we checked for 2. We checked for 4, and then we got the correct answer. So then 2, which is positive 2, is your answer. So you can kind of work your way backwards. If you're confused as to figuring out the GCF, sometimes you have like complicated or like bigger coefficients, and it gets really hard to like eyeball the expression and figure out the GCF right off the top of your head. In that case, you can use this way of like working your way backwards. So for this problem, this is another again practice problem. So this is a problem with that negative coefficient, right? So we are going to start off by grouping the first 2 terms as our first group, and then our second 2 terms as a second group. And once we do that, we do factoring. We do GCF, GCF1, GCF2. So my first GCF, I asked myself, what is the GCF of 3 and 3? It's 3. And then x and then x squared, they have a common factor of x. Once you figure that out, you divide each of the terms using your GCF. Well, the first term is 3x squared divided by 3x. 3 cancel out. X squared divided by x is just x. And then your second term is 3x divided by 3x is just 1. So now I worked my way through for the first grouping. For the second one, I already know that it's going to be a negative GCF because my leading coefficient is negative. So I just already put a negative sign in there. And I asked myself, what is the GCF of 10 and 10? It's 10. And my GCF actually cannot have a variable because not all the terms in there have a variable, which makes x not be a common factor, right? Once you figure that out, you're supposed to divide each of the terms using your GCFs. And negative 10x divided by negative 10 is just x. They cancel out. Negative 10 divided by negative 10 is just 1. Also like positive 1, right? We have the common factor. We have x plus 1 and again x plus 1. So we probably did it right. So now let's factor out the common factors. Once we do that, we combine the GCFs. And that is your final answer. Okay, so this is more of like a complex, I would say, factoring problem. But we are still going to work our way through this problem because we know that we will have to do grouping as we see 4 terms in here, right? And it is a polynomial with negative coefficients. So you have -3 and you have -16. So I know off the top of my head, I know that my GCF for the second group, it's going to be negative, right? So let's group them. Once you do that, you figure out your GCF. Number 1, so my GCF, the first GCF, so I have 1 and -3. Do they have any common factors other than 1? No, they don't. And I have p squared and I have p cubed. So then again, like I have been saying, you pick the variable with the lowest exponent, which in this case is p squared, right? So that is going to be your GCF. Once you figure out GCF, you divide each of the terms using the using the GCF. So your first term was p to the third. You divide that by p squared, and you get it. You have 3 p's at the top, 2 p's at the bottom. Well, you will be just left with 1 p, right? And then for the second part, you have -3p squared divided by p squared. -3 divided by 1 is -3. So -3 divided by 1 is -3. P squared divided by p squared, they cancel out. So -3 is your answer. So we got p and then we got -3. Oops. So I already know and I already told that our GCF for the second grouping is going to be a negative number. And I asked myself, what is the GCF of 16 and 48? What is the greatest common factor of 16 and 48? It might be a little hard to guess the GCF because they're both like big numbers, but the GCF is actually gonna be 16. And once you figure out your GCF, once you figure that out, you're supposed to divide each of the terms using your GCF, and your first term is -16p, and you divide that by your GCF, which was -16. And -16, they cancel out. You're just left with p. And then you have 48, and if you divide that by -16, you are supposed to get -3, because again, positive divided by negative is negative. 48 divided by 16 is 3. Then, if you take a look, you have the common factors, right? So you have the common factors in there. So then you know that you are on the right track in terms of having common factors as an evidence that you are doing it correctly. So then you factor out the common factor, and then you put the GCFs together. Okay, so then it probably looks like we are done because, you know, we have been having 2 factors every time we did factoring using grouping so far. It's like we are factoring, but you have to keep factoring as long as the expression cannot be factored anymore. So you ask yourself, is this expression factorable? Can you factor this expression any further? Well, I think you can. And what did I say that by looking at this factor? This looks like something we did earlier, which was dots. So this one is like difference of two perfect squares. Why did I say that? Because I know that p raised to the second power, there's already a perfect square. And 16 is a perfect square because 4 to the second power gives you 16. So then that is actually difference of two perfect squares. Once you do that, you are supposed to remember how we did dots. It was p plus 4, p minus 4. So it was a squared minus b squared, which is equal to a plus b and a minus b. So now this is your final answer. This factored answer has actually 3 factors, which is something we haven't seen as of yet. But again, it is possible. So the key thing is you have to keep factoring as long as you have your expression and it looks like it can be factored further. So your final answer should be in the form that it cannot be factored any further. For this one, I actually wanted to show you guys about that reverse engineering technique. So in our this problem, right? So the step where it's going to be most effective is this one. So you figured out the GCF, you worked your way through the first group, you figured out the GCF, divided each of the terms, got it. But then you had to figure out the GCF of 16 and 48. If you could not figure that out off the top of your head, you could do this. So you already know that you have 3, right, as your factor for the first group. So now you know that is going to be a common factor. So what I'm going to do is that I'm going to write p minus 3. And I do not know my GCF in here yet. I will try to figure that out using the working your way backwards method. So I should be asking myself, p times what gives me negative 16p? Well, p times negative 16 gives me negative 16p. So negative 16 is probably my GCF. So then you verify that using negative 3. So negative 3 times what, or probably does negative 3 times negative 16 give you 48? Well, yes, it does. So negative 16 is your GCF. So if you are stuck or if you cannot figure the GCF out off the top of your head, or it's taking you way too long, you can use this way of like working backwards, and then from there it's the same thing, but it's just like one of those ways that you can figure out the GCF in a faster way, I think. So in here, actually, I have a video that goes over grouping and how to like actually factor by grouping. I'll have the video. I already have the video on Google Classroom. Please watch the video if you are confused, if you need someone else to explain. So this is actually a better, easier video to follow along, might be. So in here, actually, I have a video that goes over how to factor by grouping. So please watch the video if you are still confused, if you need some clarification, or if you need some more detailed explanation. Please watch the video. It is up on Google Classroom, and I think it is very helpful. So we are going to move on from grouping to factoring, sum, and difference of perfect cubes. Okay, so the first thing, like I just said that, not like just said, but like towards the beginning of the lesson, I was kind of telling you that if you are trying to do grouping, you should be asking yourself, is it the right place, or is the expression right for me to do grouping? Right? In the same way, you should be able to ask yourself and identify that if this expression right for you to be doing factoring by to be doing sum and difference of perfect cubes, right? I mean, literally, you can't do it if it's not like sum or like difference of perfect cubes, they have to be perfect cubes. That's the key term in here. Right? So if they're not perfect cubes, you can apply the formula that is written in here, as you can take a look. So this kind of like expressions, when you are trying to do factoring, there are so many different types of factoring, and then the only way for you to be able to figure out which type of factoring is appropriate is to ask yourself that what are the given expression, what are the given criterion, right? What is the given expression have? What am I supposed to do with it, right? So the hint for using these formulas for simplifying sum and difference of perfect cubes is literally to have perfect cubes. Okay? So let's look at the formula that we have in here. The first one is actually sum of perfect cube. And like you see in here, a to the third power, the third power is an indication that it's a perfect cube. And the same way, b to the third power is the indication that it's a cube. It's a perfect cube. And then I should be able to give myself a tag as to like, okay, so these are like sum of perfect cubes, and I can apply the formula to simplify them. And what is the formula? Notice how the formula does not really have the 3 or the third powers anywhere in them. They just work with the bases, right? The base A and the base B, they work with them essentially. Right? And they have the second powers, like, occasionally I would say, but then they don't really, the third powers, they're really for you to determine or kind of like to assure yourself that, yeah, those are perfect cubes. So for the first part, you're supposed to do a plus b, so your first base plus your second base. And notice how the sign is the same as you had in here, right? So once you do that, then move on, and it's going to be a squared minus ab. So this is actually the place that needs some emphasis, because this is the place where you are going to have a different sign from here. You clearly had plus, but then this place, it become minus. So you're going to have a different sign in that place. So your the first sign is going to be the same sign. The second sign is going to be the different sign. And then the third sign, like it says in here, is always, always, always a positive sign. So positive, not positive, but the same sign, different sign, always positive sign. Same sign, different sign, always positive sign. Okay, try to remember the pattern, kind of like draw it in your head, so that, or like, plan it out in your head so that you remember them. And then it's going to be b squared. So a plus b, if it's a sum of, so if you're working with like, sum of two perfect cubes, it's going to be a plus b, and then a squared minus ab plus b squared. Okay, so that is all with your first formula, which was again sum of perfect cubes. And the second formula is obviously the difference of perfect cubes, as you can already tell by the negative sign in here. It's the same thing, a cube, b cube, and the kids should tell you that these are perfect cubes. And then you are supposed to have the same sign, right? So it's the same thing. So whatever sign you have in here, it's going to be the same sign as your first sign. So the first sign is the same sign. The second sign is a different sign. So then if you had plus, it's going to be obviously, if you had minus, it's going to obviously be plus. And then your third sign, like always, it's a positive sign. Okay, so try to kind of like plan out or picture out the differences between the sum and then the difference formula, and then it's going to be easier for you. In the second, not the second, but in the following slide, I actually have a table for you guys, and it goes over the perfect cubes, the cube roots, because this is like very essential for you guys to kind of like see, oh, the expression is actually a perfect cube, or like a like sum of a perfect cube or difference of a perfect cube, because whenever they're going to give you expressions and then you will be asked to factor them, they will never give you two perfect cubes in that like in the cubic form. They're not going to give you in that form, like with the cube power, or the third power. They will always give you, or for the most part, they will give you a variable raised to the third part, and they will just give you a number. And then seeing that number, you should be asking yourself, is that number a perfect cube? And the way you determine if it's a perfect cube or not is by cube rooting it. You cube root the number, and then you see if it's a perfect cube or not. So 1 is a perfect cube. 8 is a perfect cube. 27 is a perfect cube. In fact, all of these numbers is a perfect cube, not because it says in the top that they're perfect cubes, but because if you multiply a number 3 times, you should be able to get those numbers, right? So 1, if you multiply 1 3 times, so 1 times 1 times 1 gives you 1. What number? So there's actually a number that if you multiply 3 times, you should get 8. So it's 2 times 2 times 2. Notice how I'm multiplying the exact same number 3 times. So if you're trying to determine the perfect cubes, you should be able to ask yourself, oh, is there a number that if I multiply 3 times, like the same number 3 times, I should get the result that I'm looking for, right? So for 27, it's actually 3 times 3 times 3. I have to multiply 3 times to get 27. I have to multiply 4 3 times to get 64. I have to multiply 5 3 times to get 125. And the numbers are actually all given in here, and they were all found out using the cube root, right? So you can use your calculator to figure out the cube root of, like, big numbers like this. But what I kind of recommend is that you know at least these 7. These are like the most common ones, but moving down, 1000, this one is like another common one. But like these 2 or like, other ones, they're not like that common. Numbers from 1 to 10, these are the most common ones. And you guys should be able to kind of like know them, or kind of like, come up with a way to like memorizing them or remembering them. It's given in here actually that 1 cube gives you 1, 2 cube gives you 8. So you guys kind of can kind of like look at this and figure out a way to remember them. They will be actually very, very, very essential for you. Okay, so our first practice problem is this. And for this, I have to know the formula of a cube plus b cube. Because I know that it is a sum of perfect cubes. And how do I know it's a perfect cube? I'll tell you in like 5 seconds. And that is my formula in there. Notice this, the signs, the first one is the same, second one is different, and third one is always the positive sign, okay? You might be given the formula, you might not be given the formula, depending on your exam. So, try to kind of like remember the formula as well. So, how do I know that I have to use the formula of like sum of a perfect cube? Well, I know x to the third power, that is a perfect cube. And I know 27, that is exactly 3 times 3 times 3, like I just said. So which is also 3 to the third power, which makes that a perfect cube as well. Because in other words, if you cube root a 27, you get 3, right? So now that I wrote that, I have actually assured myself that it is sum of a perfect cube, and I just have to like plug and chug into the formula. This x is my a, and then the b is 3. X to the third power is now my a, and 3 to the third power is now my b. It's just, okay, I'm gonna write that in here. A is my x, and b is the 3. The power is not like included in the formula. So please do not take 3 to the third power as your b or x to the third power as your a. So now I'm just going to use the formula. So the first part is a plus b. So it's going to be x plus 3. And it's a squared, which is x squared. So which is x squared. And then it's negative ab. So it's going to be negative 3x. And then it's plus b squared. So plus b is my 3 squared. And you guys can simplify that as this. Plus 9, because 3 squared is actually 9. Or instead of writing 3 squared, you can totally jump from like the formula to like this step. But I just wanted to show you that how I got that 9. That is because of the 3 squared power, which could be simplified. So this is your final answer. Even though this is a trinomial, I could do like trinomial factoring, but then this is not factorable, so I'm just going to leave it in this form. So this is another practice problem, and this is, I think, difference of perfect cubes. Well, now you can like ask me, wait, how did you see that this is a difference of perfect cubes? Because it's like this and this. There are like actually so many ways this can go wrong, and I'm gonna go over them after I kind of write down the formula. So that is actually my formula, and notice about the signs. The first one is the same, the second one is the different one, and the third one is always the plus sign, okay? So now if you look at this problem, the first way that this can go wrong is that if you already think that the first problem is like, so if you do like this, so then, I mean, even if that way, you have to know that 81 is actually, so 81 is not a perfect cube, right? I know that because on the chart we did not have 81, and it's like 81, if it was a perfect cube, right, you would have been like a number lower than 10 raised to the third power, but it was not on the chart. And the chart actually had all the numbers, including 10 and then lower, and then the perfect cubes for them. So is this then not like difference of a perfect cube? It actually is difference of a perfect cube, but it might not be noticeable that easily, because even though I see m to the third power, I can't think of, like, 81 is not a perfect cube, so I can't think of a number that if I raise to the third power will give me 81. So then that's a problem. Well, something that I can do to this expression to make it look more like difference of a perfect cube is by factoring this problem. What? Do you just tell me that we factored this problem twice? Yeah, I mean, we have factored problems twice, but for this one, before we do difference of perfect cubes, we have to factor out the GCF. There's actually a GCF of 3. So if you factor out the GCF, which I said was 3, well, first of all, how do I know that the GCF is 3? Well, I have 3m cubed and I have 81, right? And then the GCF is like, so I know my GCF is going to be a number because both of these terms, they have 3 as their common factor. So I'm going to take that as my GCF. And then I know my GCF cannot have a variable. I mean, also not anything with the power as well, because I do not have a variable as my common factor. So I can't have a variable in my GCF. So it's just going to be a number, which is, like I said before, 3. Once you figure that out, you divide each of the terms using the GCF. 3 divided by 3, they cancel out. It's just m cubed, sorry. 81, negative 81 rather, divided by 3 gives you 27, negative 27. Yeah? So if you have this, now this looks more like, oh, you could have been, yeah, I can think of a number that if I multiply 3 times will give me 27. Right now it looks more like difference of a perfect cube. So what is that number that if I multiply 3 times will give me 27? It was 3. We did this in the previous problem. And now I just apply the formula. Notice my A is my M, and my B is just the 3. Do not include the power, okay? So it's A minus B, which is M minus 3, and then A squared, which is M squared, plus 3M plus 3 squared, or 9. There. That's your final answer, including the 3 as the GCF. So I, again, in here have a video for you guys. So if you felt that, doing adding or subtracting sums. So in here I have a video for you guys. It's a resource to help you understand sum and difference of perfect cubes a little better. So please watch it if you are still confused, and if you need some extra explanation. It's a very comprehensive and easy to follow video. With that being said, that is the end of today's lesson. I hope it was helpful, and I will see you guys next week.